Hello viewers, I welcome all of you in my video. In this video, I will discuss a real life example that has been solved in Minitab that is related to the regression analysis, a simple regression analysis. I will discuss regarding the problem statement, after that the data that I have collected for the problem, its model adequacy and two transformations using logarithm and square root. After that, I will conduct the analysis. I will tell you that how to transform the data, and in the end we will discuss about detailed report writing and tables formulation. So let's start this video. In this video, I will discuss about assessment of the transport sales by using regression analysis. So transportation methods that has been used, employed by the government in various countries, just like you can say metro or orange lines, green lines, or you can say the train system. So I have taken one explanatory variable, that's the distance from the capital or distance from the city, and the response variable is sales. So I will check that what is the effect of explanatory variable or dependent variable on our response variable, that is sales. We will analyze the data, and in the end we will formulate a regression model in order to predict the response variable at any value of the distance from the capital over explanatory variable. For this purpose, I have taken the data distance from the capital in my country Pakistan, and it serves as an independent variable x, and the actual ticket sales per station destination per month, it is taken as y or dependent variable. I have collected 20 data points, and based upon these data points, initially I will check the model adequacy. I have drawn few graphs in order to illustrate you that how model adequacy can be checked. We have few assumptions before analyzing the data. The assumption number one is the normality of the data. So in order to check the normality of the data, I have drawn normal probability plot for the residuals, and also in order to check the normality, I have also drawn the histograms. Histogram is one of the method in which we can check the distribution of the data. So from the figure A and the figure C, we can observe it depicts us that our data follows normal distribution. Our second assumption is whether independence, that whether the data, and is there any correlation between the data, means that is there any relation between the following and preceding values. So in order to check the independence assumption, I have drawn an graph in which I have plotted the residuals versus observation error, and it is quite clear that all of the values, there is no any correlation between, I mean that there is no continuous up and no continuous down, no 5 or 6 points are continuously going upward or continuously going downward. So there is the assumption for the independence has been validated. The last assumption is equality of the variance, that whether our data has equality of the variance or not. How we can check? There is a dotted line clear to you people in the figure B. You people can see that the data is almost, the data points are almost equal above this line and below this line. So we can say that our data has equal variance, or it validates the assumption of the variance equality. In the figure E, I have drawn the residual plots for the independent variable, that is distance from the capital city. So in this graph, you can see again for the independent variable, the number of data points below the line and above the line are equal. So the equality of variance for the independent variable is also satisfied. Now we will have to write down all what we have analyzed or what we have checked. So this is a graph for the model adequacy. In this we will see that the figure A and C depicts the normality assumption has been satisfied, no outliers has been observed. Figure B depicts that equal number of data points on both sides of the central line, so equality of variance also satisfied. Figure 1D depicts that no correlation exists, so independence variable has been also satisfied. So this was about the model adequacy. Then after that we will formulate our hypothesis, that our hypothesis will be null and alternate hypothesis. As this is a simple regression analysis. So there is only one independent and one dependent variable. So we will say that the distance from the capital city, that is X, does not statistically predict over dependent variable, that is actual sales per station. Means there is no relation or no effect of distance from the capital city on the sales. And alternate hypothesis say that no, the distance from the capital city, it statistically predicts over ticket sales per station. So in order to check that, we will formulate our regression model. So first of all, we will say that our whatever our explanatory variable and dependent variable. After that, we will write down that in which software we will run the data analysis. So I have written that in the Minitab I will run the analysis at significance level 0, alpha is equal to 0.05. Further, I will define the criteria that if the p value obtained for the model or for the independent variable, explanatory variable, is less than the significance level 0.05, we will reject the null hypothesis and our model will be significant for the prediction. Okay. So if the probability is regression, then the significance level over regression will be declared as significant, else it is insignificant. So when upon analysis, it is clear to us that the model summary of the regression analysis, it says that 16.15% variation has been explained by the model. Further, the model summary explained that distance from the capital is insignificant variable. As I have performed the analysis in the Minitab, so let's go to the Minitab and I will draw there the whole you can see graphs and analysis for you people. I have opened the Minitab file. In the column C2, you can see that I have the variable distance, and in the column C3, I have the actual ticket sales. You will have to go to stat, then regression, again a regression, and again in the last fit regression model. In the fit regression model, you will have to select your dependent variable. So my dependent variable is actual ticket sales per station, and my continuous predictor is distance from the capital city. You can select it like this, distance from the capital city, double click on it, or if you want to do a single click on it, just you again after that click on the select button. You will have to go to the graphs and keep in mind that please select these four graphs. These four graphs will help you in the process of model adequacy checking. Just simply click them, check them all, and then click OK for the two times. Now you got the results. For the result portion, you can click on this at the lower right corner, output only. So you will see that you will get a model summary that 16.15% variation has been explained. Okay, and the distance from the capital city has a p value of 0.079, that is greater than significance level and thus found to be insignificant. And this is my regression analysis equation. I will tell you in my report that the equation is actual ticket sales per station is equal to 8832 plus 99.8 distance from the capital city. We can explain it that 1 unit rise in the distance from the capital city will result in 99.8 units increase in the actual ticket sales per station. So that was all about the analysis, and this is our ANOVA table. And then these are my graphs. These graphs are clear to you people in the report also. So this is my ANOVA table and the equation I have already explained to you. Now we will do the interpretation of the result. That again the thing I have explained, the interpretation that model is found to be an insignificant. What is, we concluded that dependent variable has found to be have an insignificant effect on the response variable, so that we should have to go for further searching of another parameter or factors that can significantly influence over response variable. After that, I have performed the transformation. We will perform the transformation. Sometimes our data is not following our assumption. So by using the transformation, our data become normal and its variation become you can say equal. So you can clearly see that from the model adequacy that have been performed using the graphs, that the histogram graph does not seems to a good normality, following a good normal probability distribution. However, when I perform the transformation using log, the graph is found to be a good one. So now how I have performed the transformation, let's go to the Excel. So in order to perform the transformation, you will have to just use the Excel formulas on your response variable. Keep in mind, please. So if I use the log, okay, I will just have to select the response variable and then I click OK. So look at this, 10.1 is my transformation value. You can see this value also in the table, that my transformation value is 10.18. Just what I will do, I will simply drag it down and I will get the transformation values for all of them. The second transformation I have performed in my report is by using the square root. So the command for the square root is sqrt, and again I will select my response variable, I will click enter, and I can get the response variable for all of my dependent variables. Thus I can copy these values and I can use these values in my further analysis. You can also do the transformation in the SPSS. So I have opened the data in the SPSS. Now what I will do, I have my response variable in the column 1. I will go to the transform compute variable. In the compute variable, first of all apply the command or the function you want to apply, just like you can say log, and you will then select variable 1 upon which you will apply the log, and then here you will have to give the name to the variable, just like I can say it's data 1. So upon clicking the OK, you people will get the data 1 as the response variable 10.18. So basically the column 4 is now the data transform using log function. Again I will transform the data using the same using the command sqrt square root, and I will name it as data 2. Just click OK and you will get the transformation using square root. So these were the two transformations, and you people can see that after the transformation I have completely repeated the steps for the, and as I have followed for the step 1. So the model adequacy checking using the graphs, a paragraph on the model adequacy, the tables for the regression analysis, and then their interpretation, conclusions. After that I have performed the transformation using a square root command. So this was all about the regression analysis. If you have any question, my WhatsApp number, my email address has been provided. You can call me, SMS me, or email me. I'm available to you. If you have any problem, any questions, if you want to do analysis, your own analysis by me, I'm available to you for Excel, Minitab, and SPSS. And then as an evidence, I have attached the snapshots of the results as an appendix in the report. Hopefully you have clearly understood my objective to give you insight about a real life example on the regression analysis. Thanks for watching my video, and if you liked the video, please subscribe my channel and click the like button.